NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a classic binomial expansion question. We will use Newton's binomial theorem to find the term independent of x, following a clear four-step algorithm. Step 1. Express the general term of the binomial. For the expansion of open a plus b close to the n, the general term is t sub k plus 1 equals n choose k times a to the n minus k times b to the k. This is Newton's binomial theorem general term. Step 2. Set the power of x to 0 to find the constant term. We identify the power of x inside the general term and enforce that it equals 0. Power of x equals 0. Step 3. Solve for k. We choose k so that the power of x becomes 0. K is the value that makes the exponent of x equal to 0. Step 4. Substitute the found k into the general term to write the term independent of x. Then we simplify the constants to get the final constant term. Before examples, here is a powerful shortcut. If a equals a times x to the p and b equals b times x to the q, then the exponent of x in t sub k plus 1 is p times open n minus k close plus q times k, which simplifies to pn plus q minus p times k. Setting this equal to 0 gives k equals pn over p minus q, provided k is an integer between 0 and n. Example 1. Find the term independent of x in open 2x cubed plus x to the minus 1 close to the 8. We will follow steps 1 through 4 exactly. Example 2. Find the term independent of x in open 3x to the minus 2 minus x close to the 9. Again, we apply steps 1 through 4. To summarize the algorithm: 1. Write the general term t sub k plus 1. 2. Set the power of x to 0. 3. Solve for k. 4. Plug k back into the general term. In this lesson, we will find the term independent of x in the expansion of left parenthesis x squared plus 2 over x right parenthesis to the 9th power. We'll use the binomial theorem, simplify exponents carefully, and then pick the value of k that makes the x power 0. Rule: Newton's binomial theorem, general term. T sub k plus 1 equals n choose k times a to the n minus k times b to the k. Here is x squared, b is 2 over x, and n is 9. Let's write the general term for our binomial. Step 2. Simplify the powers of x in the general term. We have x to the 2 times 9 minus k multiplied by x to the negative k. Adding exponents gives x to the 18 minus 3k. So the general term becomes n choose k times 2 to the k times x to the 18 minus 3k. Step 3. A term independent of x has exponent 0. So we set 18 minus 3k equal to 0 and solve. That gives k equals 6. The independent term is therefore t sub 7 because k plus 1 equals 7. Step 4. Compute that term. Plug k equals 6 into the simplified general term. T sub 7 equals 9 choose 6 times 2 to the 6th. We can compute 9 choose 6 as 9 choose 3, which equals 84. 2 to the 6th is 64. Multiplying gives 5,376. That is the constant term in the expansion. Summary: the term independent of x in left parenthesis x squared plus 2 over x right parenthesis to the 9th power is 5,376. We'll solve it cleanly using the binomial theorem term formula. Step 1. Write the general term of the binomial expansion. The rule says t sub k plus 1 equals n choose k times a to the n minus k times b to the k. Here, n is 10, a is x squared, and b is negative 2x. So the general term becomes t sub k plus 1 equals 10 choose k times open parenthesis x squared close parenthesis to the 10 minus k times open parenthesis negative 2x close parenthesis to the k. Step 2. Simplify powers of x and constants. First, expand the powers separately. X squared to the power 10 minus k becomes x to the power 2 times 10 minus k, and negative 2x to the k becomes negative 2 to the k times x to the k. Next, combine the powers of x by adding exponents. That gives x to the power 20 minus k multiplied by 10 choose k times negative 2 to the k. Step 3. Match the power of x. We want x to the power 16, so set 20 minus k equal to 16. Solving gives k equals 4. Step 4. Substitute k equals 4 into the term formula. That gives t sub 5 equals 10 choose 4 times negative 2 to the 4th power times x to the 16. Step 5. Compute 10 choose 4. Recall the binomial coefficient formula. N choose k equals n factorial over k factorial times n minus k factorial. So 10 choose 4 equals 10 factorial over 4 factorial 6 factorial, which simplifies to 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1 equals 210. Step 6. Calculate the coefficient and write the term. Negative 2 to the 4th power equals 16. So t sub 5 equals 16 times 210 times x to the 16, which equals 3,360x to the 16. Therefore, the coefficient of x to the 16 is 3,360. Welcome! In this lesson, we will find the fifth term of the expression x plus 2x cubed, all raised to the power 17, using the binomial theorem. First, let's write the problem. The general term of a binomial expansion is t sub k plus 1 equals the binomial coefficient n choose k times a to the n minus k times b to the k. Here, at equals x, b equals 2x cubed, and n equals 17. So our general term for this expression becomes t sub k plus 1 equals 17 choose k times x to the 17 minus k times 2x cubed to the k. The fifth term corresponds to k equals 4 because the index k starts at 0. So t sub 5 equals 17 choose 4 times x to the 13 times 2x cubed to the 4th. Now, simplify the powers. 2 to the 4th is 16, and x cubed to the 4th is x to the 12th. So t sub 5 equals 17 choose 4 times x to the 13 times 16 times x to the 12. Finally, combine the powers of x. X to the 13 times x to the 12 equals x to the 25. So the fifth term is 16 times the binomial coefficient 17 choose 4 times x to the 25. That's our answer. In this lesson, we will find the x-independent term in the expansion of left parenthesis x minus 1 over x squared right parenthesis raised to the power 3n. We will follow a structured 5-step algorithm. Step 1. Write the general term of the expansion. For a binomial a plus b to the m, the k plus 1th term is combination m choose k times a to the m minus k times b to the k. In our case, a is x, b is negative 1 over x squared, and m is 3n. So the general term is t sub k plus 1 equals combination 3n choose k times x to the 3n minus k times negative 1 over x squared raised to the k. Step 2. Simplify the term by combining powers of x. Distribute the exponent k to get negative 1 to the k times x to the negative 2k. Then multiply with x to the 3n minus k. Exponents add, so the power of x becomes 3n minus k plus negative 2k, which is 3n minus 3k. Thus, t sub k plus 1 equals negative 1 to the k times combination 3n choose k times x to the 3n minus 3k. Step 3. To find the term independent of x, set the exponent of x to 0. That gives 3n minus 3k equals 0. Solving for k, we get k equals n. Step 4. Substitute k equals n into the general term. We obtain t sub n plus 1 equals combination 3n choose n times negative 1 to the n. Step 5. Express the binomial coefficient using factorials. Recall that combination 3n choose n equals open parenthesis 3 and close parenthesis factorial over n factorial times 2n factorial. Therefore, t sub n plus 1 equals negative 1 to the n times open parenthesis 3 and close parenthesis factorial over n factorial times 2n factorial. To summarize the rules we used, first, the general term of the binomial expansion. Second, simplify powers and coefficients. Third, set the exponent to 0 to get the independent term. Fourth, substitute the value of k. Fifth, convert the binomial coefficient into factorial form. We will find the term independent of x in the binomial expression using the general term and a small combinatorics clue to determine n. Step 1. Write the general term. We are expanding the quantity open parenthesis, x to the 4/3 over y plus x to the negative 28/15, close parenthesis, all to the n. The general term t sub k plus 1 is binomial n choose k times x to the 4/3 over y to the n minus k times x to the negative 28/15 to the k. Step 2. Use the sum of the first three binomial coefficients. We are given that the sum of binomial n choose 0 plus binomial n choose 1 plus binomial n choose 2 equals 79. Recall, binomial n choose 0 is 1, binomial n choose 1 is n, and binomial n choose 2 is n times n minus 1 over 2. So we have 1 plus n times n minus 1 over 2 equals 79. Multiply by 2 and simplify to get n squared plus n minus 156 equals 0. Step 3. Solve the quadratic for n. Using the quadratic formula, n equals negative 1 plus or minus the square root of 625, all over 2. That gives n equals 12, or n equals negative 13. Since n must be a positive integer, we take n equals 12. Step 4. Substitute n equals 12 into the general term. So t sub k plus 1 equals binomial 12 choose k times x to the 4/3 over y to the 12 minus k times x to the negative 28/15 to the k. Step 5. Simplify the powers of x and y. Collect the powers of x and of y. The exponent of x is 4/3 times 12 minus k minus 28/15 times k. Simplifying, that gives 240 minus 48k, all over 15. The exponent of y is k minus 12. Step 6. Set the exponent of x equal to 0 to get the independent term. We solve 240 minus 48k over 15 equals 0. Multiply by 15 to get 240 minus 48k equals 0. So k equals 5. Step 7. Write the independent term. Substitute k equals 5 into t sub k plus 1. The independent term is t sub 6 equals binomial 12 choose 5 times y to the negative 7. Quick challenge. Why did we set the x exponent to 0? Because the independent term does not contain x, so its power of x must be 0. Must be 0. In this lesson, we will find the x-independent term in the expansion of the binomial. We will carefully apply the general term of the binomial expansion, simplify exponents, combine fractions, and set the exponent of x to 0 to isolate the constant term. Step 1. Write the general term. For the expansion of the expression we have, the general term t sub k plus 1 is the binomial coefficient 10 choose k times the first part to the power 10 minus k times the second part to the power k. Using the exponents inside each part, the first part is x times x to the negative 1/3, and the second part is x to the negative 2/7. So the general term is t sub k plus 1 equals 10 choose k times the quantity x times x to the negative 1/3 to the power 10 minus k times the quantity x to the negative 2/7 to the power k. Step 2. Simplify the powers of x. Inside the first parentheses, x times x to the negative 1/3 equals x to the power 1 minus 1/3, which is x to the 2/3. Therefore, t sub k plus 1 equals 10 choose k times x to the 2/3 to the power 10 minus k times x to the negative 2/7 to the power k. This is 10 choose k times x to the fraction 20 minus 2k over 3 times x to the negative 2k over 7. Step 3. Combine the exponents with a common denominator. We have the exponent as 2/3 times 10 minus k minus 2/7 times k. Using a common denominator of 21, we get 20 minus 2k over 3 equals 140 minus 14k over 21, and 2k over 7 equals 6k over 21. Subtracting gives 140 minus 20k over 21. So the term is t sub k plus 1 equals 10 choose k times x to the power 140 minus 20k over 21. Step 4. To get the term independent of x, we set the exponent of x to 0. So we solve 140 minus 20k over 21 equals 0. Multiplying both sides by 21 gives 140 minus 20k equals 0. Therefore, 20k equals 140, so k equals 7. Step 5. Write the independent term. Since k equals 7, the independent term is t sub 8. Substituting k equals 7 in the general term yields t sub 8 equals the binomial coefficient 10 choose 7. The x part becomes x to the 0, which equals 1, so only the coefficient remains. Step 6. Calculate the binomial coefficient. 10 choose 7 equals 10 factorial over 7 factorial times 3 factorial. That simplifies to 10 times 9 times 8 over 3 times 2 times 1, which equals 120. So, the constant term is 120. Final answer, t sub 8 equals 120. In this lesson, we will find the value of n so that the third term of the binomial expansion is independent of x. The expression is left parenthesis, the cube root of x squared plus 1 over x right parenthesis to the power n. Step 1. For a binomial a plus b to the n, the r plus 1th term is n choose r times a to the n minus r times b to the r. The third term corresponds to r equals 2. Here, a is the cube root of x squared, and b is 1 over x. So t sub 3 equals n choose 2 times a to the power n minus 2 times b squared. Step 2. We simplify the powers of x. The cube root of x squared to the n minus 2 becomes x to the power 2/3 times n minus 2. And 1 over x squared becomes x to the power negative 2. So t sub 3 equals n choose 2 times x to the power 2/3 times n minus 2 times x to the power negative 2. Step 3. We combine exponents of x by adding them. The exponent becomes 2/3 times n minus 2 minus 2. That equals 2n minus 4 over 3 minus 2, which equals 2n minus 4 minus 6 over 3, and that simplifies to 2n minus 10 over 3. So t sub 3 equals n choose 2 times x to the power, open fraction, 2n minus 10 over 3, close fraction. Step 4. To be independent of x, the exponent of x must be 0, because x to the 0 equals 1. Set 2n minus 10 over 3 equal to 0. Multiply both sides by 3 to get 2n minus 10 equals 0. Then 2n equals 10, so n equals 5. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.